Hello and welcome to yet another lecture on basic electrical engineering, paper code ESEE101. Myself, Prathita Roy, Assistant Professor of Dr. Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Okay. My topic is superposition theorem. Lesson objective. After the end of this topic, students will be able to explain and solve numerical problems related with superposition theorem. Hello and welcome to yet another lecture on basic electrical engineering. Myself, Prathita Roy, Assistant Professor of Dr. Chandra Degree Engineering College, Electrical Engineering Department. Till now, we have learned about the Thevenin's theorem, Norton's theorem, and the problem means how we can easily able to provide solution using those theorems. Today we will learn about the superposition theorem and how we can able to approach to a particular solution with the help of superposition theorem. So superposition theorem states that in a linear bilateral network containing several sources, or the current through or voltage across any branch in the network equals the algebraic sum of all the currents or voltages of each individual source considered separately with all other sources made inoperative, that is replaced by resistance equal to their internal resistance. It may be noted here that while removing the voltage source, it should be replaced by its internal resistance if any, or by a short circuit, and while removing the current source, it should be replaced by an open circuit. Superposition theorem is applicable only to linear networks, both AC and DC, where the current is linearly related to the voltage as per Ohm's law. So, according to the superposition theorem, what is the procedure of a superposition theorem? Select one source and replace all the other resources by their internal impedances. Determine the level and direction of the current that flows through the desired branch as a result of the single source acting alone. Replace steps 1 and steps 2 using each source in turn until the branch current components have been calculated for all sources. Algebraically, sum of the components current to obtain the actual branch current or currents. So let us take an example in order to view the superposition theorem. So superposition theorem. We will approach with the help of that is given superposition theorem. So we will approach in order to find a solution with the help of superposition theorem. A particular solution. So let us do it with the help of superposition theorem. So let us take a problem. With the help of superposition theorem, we have to approach a particular solution. This is 10 volt. This is 5 ohm. is 5 ohm, this is 5 ohm, and this is 10 ampere. This is 10 ampere. So with the help of the superposition theorem, we have to find the value of IA, that is current flowing through the, so we have to find the value of IA. Say that is the current flowing through the 5 ohm resistance. With the help of the superposition theorem, we have to find the value of IA. Okay, so superposition theorem states that we have seen that in this problem there are two sources. One is the 10-volt voltage source, this one, and one is the 10-volt 10 ampere current source, this one. So superposition theorem states that only one source will be activated at a time. Means if there is two sources, we have to activate only one source at a time. So let us take, if means if there is a voltage source is there, it will be short circuited, and if there is a current source is there, it will be open circuited in order to replace by their internal resistance. So let's the current sources activate. First is let the current sources activate and the voltage source is short circuited. Current source is activate and the voltage source is short circuited. The equivalent circuit will be become now this one. The equivalent circuit will be become this. Current source is there and we have short circuited the voltage source. Only one source at a time. So what we have done, we have short circuited the voltage source. This part is short circuited. The current source is there in the circuit. So this is 5 ohm, this is 5, and this is 5, and this is 10 ampere. So first, when the 10 ampere current source is activated, 10 ampere current source is activated, we have to find the value of I1. There is a current, we have to find the value to the IA, means the current flowing through the 5 ohm resistance. So we have to find the first value of I1. So it is seen that the current, it is seen that the current that is 10 ampere that is coming through the 5 ohm, it is divided here into two parts. One is going through that particular part and one is going through that particular part, is known as IA. And it is routed back through that part, and at that point there's two current are coming, and it is that the 10 ampere is also coming in this way, coming back to that 10 ampere. Means here that these two are connected in parallel because the current is divided. One is I1 and one is, say this one is 10 minus I1 current. So means that these two are divided. Current are divided means those two are connected in parallel. So in order to find the value of the I1, so what we will do means is the total current, that is the 10 ampere, and if the two resistance, that is the 5 ohm and the 5 ohm, are connected in parallel, so means the resistance at the opposite branch, means we have to find I1 means current through that branch. So resistance of the opposite branch is 5 ohm by summation of the two resistance that is connected in parallel, that is 5 ohm and 5 ohm. So it is given that the current is I1 that we have get when the 10 ampere source means is active, is the the 5 ampere. That is the value of I1 when 10 ampere source is active. Okay, the total current will be the I1 is the 5 ampere when 10 ampere current source is active. This is the value of when 10 ampere is active. So now the another source is the 10 volt. So when 10 volt source is active, what is the value of current? Now we are going to the case number 2. We are going to the case number 2 where the 10 volt, two sources. One is the voltage source. First we have seen the current source is activated and the voltage source is short circuited. Now we will see the voltage source will be activated and the current sources will be open circuited. And the current source will be open circuited. So this is the step number 2. Here the voltage source, that is 10 volt source, is activated and the current source, the 10 ampere current source, will be open circuited. So let us draw the figure. The figure is given that this 10 volt is activated, 10 volt is activated, and here it is open circuited. That current source is open circuited. This one is open circuited. So no current will be flowing through this. This is the 10 volt and this is 5 ohm. This is also 5 ohm and this is 5 ohm. So we have to find the value of this one, the I2 current. We have to find the value of I2 current here. What is the value of I2 current? So let's go to the solution. That when this is open circuited means that no current, value of the current is 0. So same I2 current is flowing routed through that particular, from starting from the 10 volt and it will come back to the 10 volt. So because in that particular zone there is no current, means here there is no current is flowing because it is open circuited. So this 5 ohm resistance will not come into the play. So total current I, according to that is given in the Ohm's law, that we are using the conception of that is superposition, that we are using the conception of Ohm's law. So I equal to V by R in case of the Ohm's law, that is 10 minus 0, the voltage difference, and total resistance is 5. That is the I2, 5 plus 5. So the total resistance, the current is 10 by 10. So it is given as 1 ampere. So when the 10 voltage source is acting, the current that is flowing through the particular, when the 10 volt is acting, means the 10 ampere is open circuited and the current that is flowing to the 5 ohm resistor, that is I2, it will be this one, it will be 1 ampere. So what we have got, we have find that if the both of the parameters are operating, means when the 10 voltage source is operating, the 10 ampere source is short circuited and the current is 1 ampere, that is I2. And when the 10 ampere current is operating and 10 voltage source is short circuited, the current is given as 5 ampere. So I1 means when the 10 ampere is operating and voltage source 10 volt voltage source is short circuited, the current is 5 ampere. I2 means when the 10-volt voltage source is operating and 10 ampere current source is open circuit, the total current is I2 is I1. So total current, that is IA, with the help of superposition theorem, is the summation of I1 plus I2, that is the I1 is 5 plus 1, that is 6 ampere. That is the total current flowing through the 5 ohm resistance with the help of superposition theorem when at a time one source is activated. It's the algebraic sum that is given. That is the that is given in the theorem. That is the voltage. So their internal resistance means we have to replace this and the superposition theorem and related to the Ohm's law, and the voltage sums are the that Ohm's law thing, that is the algebraic sum of the currents to obtain the actual branch current. So all the steps that we have followed to find the current through the resistance 5 ohm, that is the IA current, with the help of superposition theorem. Let's we just check that particular thing, that this answer is right with the help of the nodal analysis. So this one I have taken, the node is VA, the highest node. I am checking that this answer is right or not. So means this, from the nodal analysis, all this voltage that the node A will be created as the highest potential VA, and all the currents must be leaving from that particular voltage. So let's, this one is IA and this one is IB. So we can use the conception of at node A, at node A, we can use the conception of KCL. Applying the KCL, we get that the KCL that we must apply at that. So at node A, applying KCL, that we get IA, that is leaving out from that node, plus IB is the current that is leaving out from the node, equal to, that is entering the node A is 10 ampere. So IA can be written as VA minus 0 by 5, plus IB can be written as VA, that we have done with the help of nodal analysis, minus 10 by 5 is 10. So from that we have obtained that 2 VA equals to 50, 2 VA equals to 60, and VA equal to 30 volt. So if I found that VA that is equal to 30 volt, you can easily find the value of IA. IA is VA minus 0 by 5, that is 0 is the ground potential. So 30 by 5, that is 6 ampere. So IA is 6 ampere. We just using the conception of KCL and nodal analysis. So it is seen that this one is equal to this one. So with the help of the cross check, it is seen that both the currents are same. That in case of the superposition theorem, and along with the, that we have tested with the help of KCL and the nodal analysis, that our answer is right or wrong. We have seen that both our answer are same, that is 6 ampere. So today we have discussed how we can approach to a particular solution with the help of superposition theorem, and we just cross-checked it that our answer is right with the help of KCL and nodal analysis. So today we'll learn about the superposition theorem and how we can able to approach to a particular solution with the help of superposition theorem. Thank you.